So we're looking at we're going to go through problems question by question on your NCFE, mock NCFE practice test. Hopefully these problems will look similar to the problems that are on your actual NCFE. They're using the same pre-calculus standards. So this will help you hopefully understand working through problems step by step. And you can choose to follow along with me or just take the test at your own pace and then use this solution video to help you help you go over it. So the first problem is f of x is equal to 700 over 1 plus 2 times 0.6 to the x. And this models the number of bacteria in the petri dish over time. What does the 700 represent in the context of the problem? So the answer is there are at most 700 bacteria in the petri dish at any time. And the reason I can tell you this answer right away is because if you can recognize this as a logistic function, the numerator divided by that one there, that constant that's added, constant that's in the denominator is going to be the carrying capacity of a population. And 700 is the carrying capacity of the highest you can reach. If, however, you do not remember the properties of recognize this function to be a logistic function and recognize the numerator divided by the constant that's by itself in a logistic function to be the carrying capacity, then you can just plot the function in Desmos. 700 over 1 plus 2 times 0.6 to the x. And if you are able to interpret the graph and understand what it means, the x-axis being time and the y-axis being the level of bacteria, hopefully you're going to be able to interpret that at a certain point the highest level of bacteria that you're going to get is 700, regardless of how much time increases for the bacteria in the petri dish. So that's, if you don't memorize the characteristics of the function, if you know about the problem in context and can interpret it and graph it, you can still get this question right. Question 2. A2 is equal to 6. A5 is equal to 20.25. Find the sum of the first 10 terms in this geometric sequence. So, excuse me. Thank you. We have a sequence of numbers. All right, A2 is 6. So we have a first term, then a second term that is 6, then a third term, a fourth term, and a fifth term. That fifth term is 20.25. So there's two values you need to find. A1 and our first term and our common difference. So A1 is this term, this is A2, 6, this is A5, 20.25. And we were told this is a geometric sequence. A geometric sequence means you multiply by a term each time, but we multiply by a common ratio each time to get to the next number. So 6 times the common ratio is this third term. This third term times the common ratio is the fourth term. So 6 times r is the third term. 6 times r is the fourth term. 6 times r times r times r is the fifth term. So that means 6 times r, third term, times r, fourth term, times r, fifth term, is equal to 20.25, which means 6 times r cubed is 20.25. And I can do some calculations here. divide each side by 6. I can divide 20.25 divided by 6. That's just r cubed. And then I take the cube root of r. So to find the cube root, I raise that value to the 1/3 power. Raising a value to the 1/3 power is the same thing as taking the cube root. And that's going to give me an r value of 1.5. So r is equal to, using my calculator, using the steps there, r is equal to 1.5. Which means I'm multiplying by 1.5 for each step. Which means I divide by 1.5 to get my first term. A1 is equal to my first term. So I can do 6 divided by 1.5 to get my first term. That's going to be 4. So A1 is equal to 4. So now I need to find the sum of the first 10 terms of the sequence. So there's two ways you can do this. One is I could find the explicit form of a geometric sequence, and I think that's the easiest way to do it. The explicit form of a geometric sequence, it's going to be on your formula sheet, is A1 times r to the n minus 1 power. So that means A1 is 4 times r, which is 1.5, to the n minus 1 power. And then we can just use our calculator to evaluate sigma notation. We're finding the first 10 terms of 4 times 1.5 to the n minus 1 power. So I'll pull up Desmos, pull up my calculator, go to functions, go to miscellaneous, create a sigma notation. N is equal to 1. Here, 10. And my formula is 4 times 1.5 to the n minus 1. Put n minus 1 parentheses. N minus 1 power. It gives me 453.3203, and it might not look like a correct answer, but all I have to do is evaluate my different answer choices. So which one is 453? Is it 174075 divided by 256? Nope. Is it 177147 divided by 512? Nope. Is it 58025 divided by 128? Yes, it is. So this is the correct answer. The other way to do this, if you don't like using the sigma notation, is you can use your formula sheet. North Carolina pre-calculus formula sheet. And you can see that the sum of the terms of a geometric series is A1 times 1 minus r to the n over 1 minus r. So our first term, once again, is 4. So it'd be 4. So let's actually just put this directly into calculator. Alpha y equals A1 is 4 times 1 minus r is 1.5 to the n, which is to the 10th power, over 1 minus r. So that's going to be 1 all over 1 minus r is 1.5. Plugging in all those formulas in, and that gives me the same value. So because that gives me the same value, I have two methods to do just plugging in directly into the formula or using the sigma notation in Desmos. I actually like plugging into the formula just because you need to find A1, you need to find R, and then after finding A1 and R, you plug it into your just your geometric formula for the first 10 terms of the sequence, and you're good to go. So that's question 2. And I am going a little slower. You want to be answering these questions about 3.5 minutes. I'm going slower, but I am being thorough in my explanations. So know that in actuality, you're making the calculations that I'm explaining a little bit faster when you're actually doing them yourself. So an is equal to an minus 1 plus 7. Find the explicit form of the sequence if a1 is equal to 2. So here's the deal with a problem like this. You have to know how to convert from a recursive sequence into explicit sequence. Now this is an arithmetic sequence because what this is saying is that our first term, we have to be able to read this, our first term, a1 is 2, and the term after that, each term is equal to the previous term plus 7. an is equal to an minus 1 plus 7. Each term is equal to the previous term plus 7. So a2 is the previous term 2 plus 7, which is 9. a3 is the previous term plus 7, which is 16. You're just adding 7. So this is an arithmetic sequence, and we have to know that it's on our formula sheet, but we need to be able to recognize that formula sheet for arithmetic sequence and series. That the formula for an arithmetic sequence is an is equal to a1 plus n minus 1 times d. an is equal to a1 times n minus 1 plus d. D is the common difference, which is how much each term in the sequence changes. Hopefully it's intuitive that the common difference here is 7. You're adding 7 each time to get to the next value. So an is equal to a1, which is 2, plus n minus 1, we keep it the same, times d, which is 7. Now, this is the right answer, and just because we don't see this answer as a multiple choice option doesn't mean that this isn't right. We just have to convert it if the answer choice isn't in this form. So how do we convert it? We just distribute the 7. an is equal to 2 plus 7 times n is 7n. 7 times negative 1 is minus 7. 2 minus 7 is negative 5, so it's equal to 7n minus 5, giving us answer choice A. Okay. A1 is equal to 5. an is equal to an minus 1 plus 2. Find S13, which is the sum of the first 13 terms in the sequence. So, if you really had to, you could just in your calculator do 5 plus 7 plus 9 plus 11 plus 13 up till you get to the 13th term, and that's what you would get. But let's use, I think the fastest way to do this is a formula. The first term is 5. a1 equals 5. We have to know our common difference. Each term is the previous term plus 2, so our common difference is 2. Our formula for a term is Sn is equal to n over 2 times a1 plus an. So to find an, we would just need to find a13. To do that, we would need to find our explicit formula. An is equal to a1, 5, plus n minus 1 times d, which is 2, which means that at this point, this is all we need to, I can show you guys how to enter in the formula, but at this point, once we have the explicit form, it's very easy to find the value of the explicit form. In Desmos, we're finding the first 13 values, so I go from n equals 1, and this becomes 13, And then my explicit formula is 5 plus n minus 1 times 2. Wait. Oh. N equals 1, 5. Oh, I need to do a times symbol. Two times n minus 1. And okay, if this isn't working, you can use the summation tool on your calculator, where you go to turn your calculator on, you go to math, you go to your summation, and your summation is your variable is x. X starts at 1, goes to 13, and the formula is 5 plus 2 times the quantity of x minus 1, giving us a value of 221. But if we actually want to solve it using our formula, an, first we find a13, that's equal to 5 plus 13 minus 1 times 2. So 12 times 2. So 13 minus 1 is 12. 12 times 2 is 24. 24 plus 5 is 29. So a13 is equal to 29. And now that we have a1, a13, we can use our formula. Sn is equal to n over 2 times a1 plus an. So S13 is equal to 13 over 2 times a1, 5, plus a13, which is 29. So that just becomes 13 over 2 times 5 plus 29, which is also 221. So I've shown you both ways to get your answer of 221. You need to be able to plug it into your explicit formula and plug it into your calculator. I don't know what the issue is with perhaps what the issue is with Desmos. If I change my variable to x, I change my variable to x here. Okay, that. So looks like it's better to use your summation tool in your calculator than Desmos. Both do the same thing, so just use your calculator. Question 5. A piecewise function is shown below. X squared minus 5x plus 3 when x is less than 1. Negative 2x plus n when x is less than 1, is greater than 1. What value of n makes the piecewise function continuous? So these are the steps to make a piecewise function continuous. This is one you're going to have to do algebraically. But you have x squared minus 5x plus 3 and negative 2x plus n. Now these two functions meet as a piecewise function when x is equal to 1. So I have 1 squared, so now I'm plugging in the x value where they meet, minus 5 times 1 plus 3 has to equal to negative 2 times 1 plus n. So let's evaluate. 1 squared is 1, minus 5 is negative 4, plus 3 is negative 2. So negative 2, well wait, I think 1 squared is 1. Minus 5 is negative 4. Plus 3 is negative 1. Sorry about that. Which is equal to negative 2 plus n. I add 2 to each side. Negative 1 plus 2 is positive 1. That's equal to n. And I've solved for n. Now, if I wanted to use this on Desmos, I think it's easier to just plug in and find the value that makes it continuous. However, if 1 is equal to n, I can just plug in both equations in Desmos. X squared minus 5x plus 3. X squared minus 5x plus 3. I'm going to go back to my standard zoom. And I'm also going to type in the function negative 2x plus n. I'm going to add a slider n. And enough to understand I'm looking for the value when n is equal to 1. If the functions are going to be continuous, they have to be equal to the same value when n is equals 1. As you can see, they are the same value when n is equal to 1. If you change what the value n is equal to, the functions only intersect when n is equal to 1. So this also you can do in Desmos, but I think it's harder because it requires just as much understanding and interpretation of what you need to look for. You have to find the value of n, and the functions are continuous if at the values that they meet, they are continuous. And the values that they meet are at 1. And that's just because the first function goes all the way up to 1 and equals it, and the next function is when x is greater than 1. Alright, question 6. The limit as x approaches 0 of 4 plus x squared minus 16 over x. So I'm going to do this algebraically first, then in Desmos. I'll show you both ways. So first we have to, if we use direct substitution, we are dividing by 0. So, because we have x in the denominator. So you can't divide by 0, so we have to see if we can factor. So let's factor out 4 plus x squared. That becomes 4 squared, which is 16, plus 2 times x times 4, which is 8x, plus x squared, minus 16 over x. The 16s cancel out, and now I just have x squared plus 8x over x, which simplifies to, I factored an x in the numerator and left over with x plus 8 over x, and the x's cancel out at this point. So I have x plus 8 over 1, and now I have the limit as x approaches 0 of x plus 8 over 1, and now I can plug in that 0 in for x, and this just becomes 8 over 1, making the answer 8. Now if I want to evaluate this in Desmos, I do what I always do. I take the function and I input it directly into Desmos. 4 plus x squared minus 16 over x. So I'm plugging in the numerator. 4 plus x squared. 4 plus x squared minus 16 divided by x. Now I'm evaluating as x approaches 0. Well, let me 4 plus x squared minus 16 over x. So I'm looking at when x approaches 0. And to do this, I'm looking at 0.0001. Sorry, I mistyped this. Sorry. Okay, so here's a big thing. Don't make typos when you're actually copying in your function. So this is the typo. I typed in 4 plus x squared. I need to type in 4 plus x, then the whole thing squared over x. So now I can look at when x approaches 0. So very important that you type in the function right. Double check that, because I was just able to find that. You evaluate 0. Even if 0 is undefined, you can impart 0.00001, which is 8, and negative 0.00001, which is also 8. So the limit from both the left and the right is approaching 8, which means the answer is 8. So once again, that's two methods to get 8 as your answer. Question 7. Find the polar equation equivalent to 2y equals 5x minus 4. First, I'm going to do the algebraic method, then we need to do the Desmos method. Algebraic method, we have to memorize from polar that y is equal to r sine of theta and x is equal to r cosine of theta. So, let's make that conversion. 2 times r sine of theta is equal to 5 times r cosine of theta minus 4. Now my goal is to get all my r sines of thetas and r cosines of thetas on one side of the equation so that I can factor out my r. So I'm going to subtract 5 times r cosine of theta from each side. So now I have 2 r sine of theta minus 5 r cosine of theta, which is equal to negative 4. Then my goal is to isolate r, so I factor out an r, and I'm left with 2 sine of theta minus 5 cosine of theta is equal to negative 4. Then I divide each side by 2 sine of theta minus 5 cosine of theta. R is equal to negative 4 over 2 sine of theta minus 5 times the cosine of theta. But notice the answer choices don't have 4 in the numerator, not negative 4. So to find equivalent term, we could turn that negative, we can multiply by negative 1 over negative 1 and get positive 4 over negative 2 sine of theta plus 5 cosine of theta. And that could be rewritten as 5 cosine of theta minus 2 sine of theta. So that could also be written as 5 cosine of theta, negative 2 sine of theta plus 5 cosine of theta is the same thing as 5 cosine of theta minus 2 sine of theta, giving us 4 over 5 cosine of theta minus 2 sine of theta. That's our correct answer. Now, how do we do this in Desmos? It's very simple. We first plug in a rectangular equation. You guys, once you see this, you're not going to want to do the algebraic method I did. I just type in 2y equals 5x minus 4. 2y equals 5x minus 4. Then I type in my answer choices. R equals 4 over 5 cosine of theta minus 2 sine of theta. R is equal to 4 over 5 times the cosine, and for theta, I just write it out theta, theta, minus 2 times the sine of theta, theta. And notice, oh, they match up. Boom, blue, boom, green, boom, blue. And just by the nature of the first answer choice being the one that matches up, that graph matches up, so the first answer is the option. Ignore those dollar signs, that's a typo. Question 8. Find the y value of this polar coordinate. So here we just have to know that the y value of the polar coordinate, we have to know that y is equal to r sine of theta. So for a polar coordinate, we need to know that the y value of the rectangular coordinate is equal to r times the sine of theta. All right? So my r value is 7,990. My theta value is 30 degrees. So I get my calculator. I do mode degree and do r 7990 times the sine of theta, which is 30. It gives me a value of 3,995, and I input that directly as my answer choice. I think question 8 is quite easy. If you just got to know those formulas. You got to know y is equal to r sine of theta, x is equal to r cosine of theta. Theta is the inverse tangent of y over x, that's your reference angle, and x squared plus y squared is equal to r squared. R is equal to the square root of x squared plus y squared. All right. Question 9. Approximately how far away is the happy face from the sad face? So we have to actually just find the distance, different distances in right triangles to find these values. So the happy face and the sad face is just essentially the horizontal length of both of these triangles, all right? So make sure that you're doing something productive. If you're not, it would probably require you to have your eyes open for you to be productive. Now the tangent we can find essentially when we're drawing this problem. We need to find this value and then that value. And to do that, we're going to have to find our middle value. So we know that the tangent of 53 degrees is opposite over adjacent. So if I label this side, I'll just call this side x, and I'll solve for different variables. Tangent of 53 is equal to x over, x over, and I'll call this value x2. So opposite over adjacent, x over x2. But in order to find x, I need to use sine. So the sine of 53 is equal to x over 40, because 40 is the hypotenuse. So x is equal to 40 times the sine of 53 is equal to x. So I just take my calculator and I evaluate 40 times the sine of 53. That's equal to 31.9. So x is equal to 31.9. That's the vertical height of the triangle, 31.9. And then I can use my tangent values to find my x2, and I'm going to call this value x3. The tangent of 40 is equal to x over x3, opposite over adjacent. So that's going to be x over x3, which means here I just need to do, for 53, x is 31.29, so that's equal to 31.9 over x2, which means that's x2 times the tangent of 53 is equal to 31.9, which means that to get x2 is 31.9 over the tangent of 53, and x3 is equal to 31.9 over the tangent of 40. So if those ratios make sense to you, you can, in your calculator, do 31.9 divided by the tangent of 53. That is 23.28. You can do, oh, sorry, that's 31.9. So I'm going to do 31.9 divided by the tangent of 53. And I do 31.9 divided by the tangent of 40. That's 24. That's 38. I add the 2. 24 plus 38. That's 62. Well, that's 62.8. Well, that's 62.62, but the best answer choice is 63. So sometimes you won't have a perfect answer choice. That's okay. But that just requires you to use your trig ratios. So f of x is equal to log base 7 of x plus 1. Find the horizontal asymptote of the inverse of the function. So we need to find the inverse of the function. If y is equal to the log base 7 of x plus 1, that means x is equal to the log base 7 of y plus 1. I'm trying to isolate y, so I need to swoosh that logarithm into an exponential function. The base is 7. Swoosh, there it is, to the x. So 7 to the x is equal to y plus 1, which means that I subtract 1 from each side, and y is equal to 7 to the x minus 1. Now I need to find my horizontal asymptote. Now if I know how to interpret an exponential function, I just know that the horizontal asymptote is that y is equal to -1, knowing that my downshift is the horizontal asymptote of the exponential function. But if I don't know that, I can go into Desmos, just type in 7 to the x minus 1, and hopefully I can just see on Desmos that my horizontal asymptote is at y equals -1. Hopefully you can just kind of see that. But regardless, the answer is y equals -1. Okay. X is equal to 1 over t. Y is equal to the negative ln of t. Convert these parametric equations into rectangular form. So, once again, make sure that you are focusing to the fullest of your ability. You're trying to your fullest of your ability on the last day. X is equal to 1 over t. You isolate t. So you multiply each side, so you have tx equals 1, divide each side by x, and t is equal to, t is equal to 1 over x. Then you just plug it into y is equal to the negative ln of 1 over x. Y is equal to the negative ln of 1 over x, and at this point there's not too much you can do to simplify. So negative ln of 1 over x, that's question 11. Okay. 4/16, 6481. Find the infinite sum of the geometric sequence. So we need to look at our formula sheet. The infinite sum of geometric sequence is s is equal to a1 over 1 minus r. So we just need the first term, the common ratio, if my common ratio has an absolute value that's less than 1. So, going back to the quiz, I have answers of values of 4/16, 64 over 81. So I need to find a1. Well, a1 is 4. And you need to find r. This actually, this looks better if we go over, and that's 16/9, not 16/19. So let me go back to my brush. 4 over 1 to go to 16/9. I have to multiply 4 by 4 and 1 by 9. And then to go to 64 over 81, I multiply 16 by 4 and 9 by 9 again. So r is equal to 4/9. Then I just plug into my formula. S is equal to A1. A1 is 4 over 1 minus R, which is 1 over 1 minus 4/9. Which means S is equal to 4 divided by 1 minus 4/9. That's 9/9 minus 4/9 is 5/9. So 4 divided by 5/9. That means that's 4 times 9/5, which is equal to 9 times 4 is 36/5. And 36 over 5, 36 divided by 5 is 7.2. So that's my answer. I can also just plug A1 and R into that equation in the calculator and solve directly. Next problem. What is the approximate distance between you and the cat? So the cat is 420 feet away from this middle point, which has a 27 degrees up to the top, and there's a 17 degree up to the top of this triangle. So how will we find this out? Just quickly before we end this video, which will be about the first third. Is you have 420 feet, and so first we find the height of the tallest part of this triangle. To get that height, we have 420 here, 27 here, and we can use right triangle trig to know that for this height, the tangent of 27 is going to be x over 420, so 420 times the tangent of 27 is equal to x. So then I do 420 times the tangent of 27. I'm using my trig ratios here. That's 214, so x is equal to 214. And then from there, that's not my solution though. I need to find this value, which is 17 degrees. And you can know that the tangent of 17 degrees is equal to 214 over, I'll call this value x2. So the tangent of 17 is equal to that. x2 times the tangent of 17 is equal to 214. So x2 is equal to, and this will be an answer, 214 divided by the tangent of 17. So this value divided by the tangent of 17 degrees is 699, and that's our solution. Our closest best answer is 700. All right, see you in the next video.